Okay, so we did indifference curves, we did the budget line. So we're just continuing here with utility maximization. Like I said, the three examples, what are they basically? If I can just say them from memory, there's the most important Cobb-Douglas, then there's the linear, then there's the L shape. Yeah, they say all this utility maximization, which it is. It's us maximizing our utility, but it's going to be where the two, the U, uh, indifference curves and the budget line, it's going to be where they meet, and it's just basically going to be the condition one, condition two for both examples. So we can read through this here, which I would not. Always review from chapter 2 and chapter 3. Condition one is to just have your budget line. The budget line is purely conceptual. It doesn't change. So if the concept behind our budget line never changes, we always have the same budget line. So there it is there. We're looking for Q. We skip all the theory because we don't need it, but we do the math really easily and we forget the theory, the homework problems. But the Q1 star, Q2 star are supposed to be the quantities one, quantity two, which increases, which maximizes our utility. That, of course, is why they say that. So if we ever want to stop and read about the theory, that's perfectly okay. Yep, they talk about that optimal mix of goods one, good two. So we just go into I wouldn't say example one, but we go into situation one, strictly convex indifferent curves. The diminishing marginal rate of substitution is what that's going to be, but it's going to be the Cobb-Douglas. So we just derived this in the previous video. Yeah, remember that comes from our utility, that comes from our indifference curves, and this comes from our budget line. Yeah, so we always have the two, and we have to derive that. We have to take the partials and all that. And that's where that statement comes from there. Okay, so they do that, and there's basic concepts. I don't think we have to go through them. So we have this indifference curve. This is chapter 4, but it's exactly the same homework problems as chapter 3. This is the budget line. Yeah. So let's just kind of stay on that, and let's erase that and see what we have going on. Yeah. Uh, the red intersects right there, obviously, but it also intersects a indifference curve right there, doesn't it? Intersect an indifference curve right there. Well, that right there is for a lower utility. We always want the highest utility, so it's always going to be that one, and all the other points to the left and to the right, they simply have no meaning if we understand. I wouldn't say it because it just repeats like 5 videos. But if we understand the fact that going out from the origin, all the utilities are increasing, then we only care about that one point where the budget line and the difference curve, we care about that one point where they meet. And that's going to be, what is it? It's going to be the Q1 star. So there's little bits and pieces we forget to say, not forget, we forget to mention them, but it's honestly because they're so obvious to so many. But at that point, that's where we're going to have the Q1 star and the Q2 star for maximizing utility. Yeah. Okay, so they basically end there. That's it. Now we go on to situation 2, which is linear indifference curves, which is perfect substitutes. Remember, they break them down into the 3 cases, which we'll do. It's very easy to forget this. I'm going to draw it, but I think I'm sure after I draw it, they do it right below here. Yeah, so I don't want to get down there too quick. If we want kind of an introduction, it's literally this paragraph right here. And they say all this, but everything they're saying we've been through before, and we can kind of sum it up right down here, you know. So they break it down into this. We can memorize these, which I would never do. If I graph them really quick on like a test or something, I remember instantaneously. But I don't remember with those. I, of course, remember from the graph. We forget this instantaneously, and then if you're me, I remember it instantaneously, yes. So what we care about here We have to remember, yes, the many, many lines are going to be the indifference curves. Let's not get mixed up. The many lines are the indifference curves. The one line is the budget. Yeah, the budget line. So all the contour lines are obviously the indifference curves. That one is going to be the budget. Yeah. So we get mixed up. These are the 2 points for which we get mixed up. Those are the 2 points, the only 2 points we should ever get mixed up. We know that x equals 0 here and you have a y. We know that y equals 0 here and we have an x, but do we want situation 1 or do we want situation 2? Those are the 2 places where we should get mixed up. Well, we see that if our budget line has a lower slope, yeah, the budget line, the slope is gentler. Yeah, for the budget line, there is technically, we don't draw all of them. There are infinitely many, all the silly concepts. There are infinitely many indifference curves. That's how long it takes me to remember that. Yeah, so we do have an indifference curve right there. Yeah. But if we circle that one right there, we are on an indifference curve, which is lower at this one right here. That's the concept and the only concept. Yeah. So if the budget line has a gentler slope, we always want to take it right here, where we only care about Q1 and Q2 is 0. Yeah. On the other hand, if the budget line is steeper, yeah, then we only care about this here, where we care about Q2 and Q1 equals 0. Yeah. And you get those 2 cases. That's what you get. I don't know how much it really has to do with real life. Of course, if the slopes are the same, it literally means the budget line lies on top of the slopes are the same, then the budget line lies on top of the indifference curve, and you have infinitely many. Yeah, there you do have infinitely many. This is a Q1 star and a Q2, yeah, star. But right here, you have another Q1 star, Q2 star that works. So there are infinitely many combinations that work, infinitely many solutions of Q1, Q2 combinations, Q1, Q2 that work. They have the same. So that one concept is the one and only one concept when it comes to the linear, or the linear is perfect substitutes. That's what it's called there. Okay, so review from chapter 3. So let's move on. Everything they just said, condition 2 is summarized right there. Yeah. So the further along we go, the less important and more boring. Yeah, how to derive this in a homework problem. That's the only thing that is confusing about this, but we care about the Cobb-Douglas. And then secondary, we care about the linear, and then the kink or the L-shaped or the perfect complements, all the same thing. We care about the least. We don't care about the math with an L shape. It's just so very obvious. You know, how do we write it formally? That might confuse us, but how to do it is very obvious. You have your kink, whatever that kink is, and then you just have the budget line that intersects that, yes. So how do we write that is who cares, but that one picture is what we have to know. Okay, so now we have numerical examples. It would be hard. It's literally just a review of this video. The numerical examples go through all 3 concepts, and they do a numerical example for all 3 concepts. So let's go ahead and do that on the next video. It's going to be taking this video and just doing an example for each. So I will see you in the next video.